Hello students, welcome to another episode of All Force e-learning program. Now in this session, we shall understand about electric flux. So today's topic is electric flux. So before going to this, let's have a review of what we have learned till date, right? Since the inception, since the start, what we have learned, let's have a review. First, I was telling you charge. Charge is a fundamental property of matter where it shows a special force called electric force. Coulomb Force. The charging of a body is electrification. There are three methods of electrification. Charging by friction, charging by conduction, charging by induction. Then, later, force, the force between two charges. Like charges repel, unlike charges attract. So Coulomb has given the formula for it, Coulomb force. Force proportional to Q1 Q2 by R square. F is equal to 1 by 4 by epsilon Q1 Q2 by R square. This is the Coulomb force between two point charges. Right? Next to multiple charges, force due to multiple charges based on principle of superposition. The resultant force on any charge due to many charges around, many point charges. It is the vector sum of all the individual forces taking all of them simultaneously. Vector sum of all. So therefore that is force due to multiple charges. Later we understood what is electric field. Field is a space where there are lines of force, where there is effect of the charge. The space around the charge where the effect of the charge can be felt. So that is field. Then electric field lines. This charge influences the other charge by field, by projecting lines of force. So there are imaginary lines which we imagine between the charges by which there is mutual interaction. Electric lines. Later, electric field intensity. The force experienced by a unit positive charge when it is placed at a point in the field. Force per unit charge, F by Q is E. So later, electric field due to point charge. Force due to point charge, electric field intensity due to point charge. 1 by 4 by epsilon Q by R square. Then multiple charges, again the principle of superposition. Then dipole, two equal and opposite charges. Positive charge, negative charge, together at some distance. Electric dipole. Then field due to dipole on the axial line, on the equatorial line, at an arbitrary point. Later, now we shall talk about electric flux. Now, what do you mean flux? In Latin, flux means flow. It's flow. Now, electric flux, actually electric field flux. Whenever there is a charge produces a field around itself, and this field, the effect of this is felt by the other charge in the presence of the field there. So, the measure of that field can be done by this flux. Electric flux. Flux mean group of lines. Actually, flux is pertaining to vector field. Electric flux is pertains to electric field. So, electric flux regarding electric field. So, electric flux phi, it is defined as the measure of number of lines of force passing through a particular space. So it is actually the measure of number of lines of force. Electric flux mean it is the measure of number of lines of force passing through a particular space, a fixed space. The measured number is called electric flux. Right? This electric flux phi, it is a scalar. It is a scalar. Even though it is a scalar, it can be positive, negative, and can be zero. Based on the direction of the flux and the area element, we get positive, negative, and zero values. It's a scalar quantity. It is just a mere number. It is the number of lines of force. The measure of number of lines of force passing through a particular space. You consider a particular space. How many number of lines of force are passing through that space? Now that measure, the number, is called electric flux. Now electric flux, how do you measure electric flux? Electric flux is measured in units. Units for electric flux It is measured in Newton meter square per Coulomb. Actually, the first simple unit, Newton meter square per Coulomb. Now, in this one, if I write Newton meter into meter by Coulomb, Newton into meter is joule. Work, force into displacement, work, joule. But joule per Coulomb, we have another unit called volt. So, this is finally volt meter it is. So, the units for electric flux, either Newton meter square per Coulomb, joule meter per Coulomb or volt Coulomb. Mostly we use the unit volt Coulomb. So, the units are like this. Now, the dimensional formula of flux. The dimensional formula of flux. Flux is actually given, dimensionally flux, it is Newton meter square per Coulomb. Newton is force, mlt minus 2. Meter is length L square by charge is IT. So when I take these things up, I get m power 1, L power 1 and 2, this is L power 3, T power minus 2, this 1 when it goes up it is minus 3, I power minus 1. So it's m1 L cube T minus 3 I1. This is the dimensional formula of electric flux. Units, voltmeter. Dimensional formula m1 L cube T minus 3 I minus 1, and this is a scalar. It's a scalar. It has no direction. In fact, it is the dot product of two vectors. We'll come across. We'll measure. So it's a scalar. Even though it is a scalar, the flux can be positive plus phi or minus phi or even 0 sometimes. Right? Even the scalar, it's not like mass where it is only positive. It's not like that. It can be positive, it can be negative, it can be 0 also. So let us understand when it is positive, when it is negative and when it is 0. So electric flux is the measure. It is the measure of number of lines of force passing through a space enclosed. Suppose if I consider a space area element. Before going to this, let us understand area element. Suppose if I take an area element, let's say my hand like this. This is the area. This area element, this is a vector quantity ds bar or dA bar. In some books it is defined as dA bar. So its area element is ds. What is ds? Area element. It is the magnitude of this area ds into n cap. N cap is the unit vector. It is the unit vector normally away from the surface. Suppose if I take this area, this is the area element, then for this plane the normal is like this. So normally away from the area, that is the unit vector. So ds bar is the magnitude into n cap, where n cap is the unit vector normally away from the surface. So therefore area element, this is ds. Now ds bar, it is the area element, it's a vector there, area element is a vector. Now electric flux, later after electric flux there is another term defined as electric flux density. It is defined as electric flux density. You know electric flux density, it is termed as electric flux density, but it is nothing but the electric field intensity, the strength of the field, the measure of the strength of the field, the characteristic property of the field there. Now this measure is E. It is also termed as electric flux density. Now it is defined as, electric flux density is defined as the electric flux, the measure of the electric flux per unit area of that element. So if I consider an area element A, for example, through that area how much electric flux is passing through. So the electric flux density E bar is phi by A, flux per unit area, right? So electric flux phi by unit area A. So from this, if E is equal to phi by A, then by cross multiplying I get flux is equal to E into A. Simply it is E into A, but actually in vector form if I write it, it is E bar dot A bar it is. So flux phi is E bar dot A bar. Isn't it? So flux, electric flux, it is the dot product of electric field intensity vector and the area of the element what you consider. It is E dot A. We know according to dot product, E dot A is mod E mod A cos of the angle between these two. Cos of the angle between these two. Now how do you represent this? Let's suppose there is an electric field going like this. A uniform electric field going like this, let this be E bar, in which I consider a area element, some area A like this, A bar, and I was just telling you the normal to that area surface, normal away from the surface denotes the area vector E bar, right? This is the electric field vector E bar, the angle between these both theta. So therefore electric flux, it is mod E mod A cos theta, cos of the angle between these both. So it is defined as the dot product. In vector form, electric flux is E dot A, and in magnitude wise it is EA. So flux phi mod A mod E mod A cos theta, where theta is the angle between these two, angle between the electric field vector and area vector. Now, if it is a uniform electric field, at any point the field, I was telling you what is uniform electric field. The electric field in which the magnitude of the electric field strength is same at all the points in the field, and the direction, magnitude and the direction is same at all the points. The electric lines of force are parallel lines, equidistant from one another. So such a field is called uniform electric field. If the field is uniform, then E is always a constant. If I consider an area element A, then this area element is A and then direction is normally away from it, then it is A bar, angle between them theta. Then for uniform electric field, in uniform electric field, then the flux phi is defined as simply A, magnitude of the electric field, A, it is cos theta. It is cos theta. Suppose if it is not a uniform electric field, if it is non-uniform electric field. Now what do I mean non-uniform electric field? In non-uniform electric field, I was defining earlier the electric field in which the magnitude of the electric field intensity and the direction of the electric field intensity differs from point to point. Either magnitude is different or direction is different, or both are different from one point to another point in that field. Now such a field is termed as non-uniform electric field. Now in this one, neither E remains constant nor the magnitude of E nor direction remains constant. So it differs, it's varying like this. The direction and this is varying. Now in this one, we cannot use this total formula like this. So let us consider a small area element ds bar. A small area element ds bar. Over this area, let's suppose in this small area, right? Let's suppose over this the electric field is constant within this small area only, not at all places. Small area, a very little small area like this. An area of a nail like this. So a small area, if I consider over this area, suppose the E value is constant, then the small number of lines of force passing through this, the measure of number of lines of force will be less. So the small flux passing through it, d phi, the small flux over this small area element. Now this is defined as E bar dot ds bar. In always remember, in non-uniform electric field, we cannot write flux of total flux phi is equal to E dot A, because this is not a constant at all the points. It differs from point to point. So consider a small area element ds, over which at all the points the electric field is almost constant. Then in that small area element, the direction is normally away from it, ds. Then the small measure of number of lines of force d phi, it is E dot ds. So small d phi is equal to E mod ds cos of the angle between these two, it is cos theta over that element. At that point on the element, the angle between the normal to the element and the electric field. So small e ds, e dot ds, e bar dot ds bar, mod e mod ds cos theta. So the small flux through the small area element d phi, it's mod e mod ds cos theta. According to the angle theta, we define the nature of the flux there. Suppose, let us consider different cases of this flux. So electric flux, I was telling you, electric flux is the measure of number of lines of force, electric lines of force passing through the area element what you have considered. Right, the element area of the element what considered, through that area element the measure of number of lines of force is termed as electric flux phi. Now this electric flux, so it is defined as E bar dot A bar. Suppose in uniform electric field itself, suppose if I am considering in uniform electric field only, in uniform electric field itself, in this one, let me consider an area element such that the angle, case 1, theta is equal to 0. The angle between the area element and the electric field is 0. That is, the electric field is like this, and the small area element which I have considered, area small ds, it is also in this direction. Both are in same direction. Right? So this is E vector and this is ds vector. Area vector. Then the flux passing through this area element. The flux through this area element. So that flux d phi through that area element d phi. We know d phi is equal to E bar dot ds bar. So d phi is equal to mod E mod ds. Now both are parallel, theta 0, they are parallel in the same direction, they are in same direction. If they are in same direction or parallel, then angle 0, it is cos 0. We know according to trigonometry cos 0 is 1. So cos 0 1 in the sense d phi is equal to mod E mod ds into 1. So therefore d phi is equal to simply E ds. E ds. This is the maximum flux. The maximum flux, and it is considered to be positive flux. Now this flux is taken as positive plus, and this flux is positive flux. What do you mean positive flux? Mathematically I am denoting it as positive. But what do I actually mean regarding this is, the flux, the lines of force, when I consider the area element, the electric field is emerging out of the area element. The electric lines of force are coming out of the area element. Emerging, they are emerging flux, emerging lines of force. So the lines of force are coming out of the thing. It is actually termed as emerging flux, emitting flux. So this flux is called either emerging flux or emitting flux. This is emitting out of the surface. It's emitting out of the surface. Coming out of the surface, then this flux is termed as positive flux. So whenever you come across a case where the electric lines of force are coming out of the surface, coming out normally away from out of the surface, then this flux is termed to be positive flux, plus flux. For example, suppose if I imagine a positive charge, we know positive charge produces positive lines of force emerging away from it. I was telling you, lines of force, a positive charge produces lines of force emerging from the point extending up to infinity. Now in this one, if I consider an area element like this, and the normal to it is outside. So from the area element, if I imagine an area element, the lines of force come out of it, emerging out of it. Wherever you consider, if I consider area element, lines of force come out of it here. Whether I consider here, the lines of force will come out of it like this. So at any point the lines of force are emerging out. Such flux is termed as positive flux. So now in this case, the electric flux is considered to be positive. You spell it out as the emerging flux or emitting flux, normally coming out of the surface. The flux emerging out of the surface, coming out of the surface. Now this is termed as positive flux, right? Case 1, first case. Suppose if I consider, suppose if I consider the flux to be like, if the lines of force, the electric field vector is in this form, the electric field vector is like this, but this time I am considering the surface area this time. If I consider the surface on this side, now whenever you take up a surface, whenever you consider a surface, there are two sides of it, this side and this side. So if I consider this one, so when I put this surface here, if I am talking about the flux coming from this surface, then the area of this is outside. So the area and the electric field both are in same direction, parallel, theta 0, positive flux. But if I consider this surface, then, so when I consider this, we know area element is normally away from the surface. It's normally emerging out, normally away from the surface, and the electric field vector is this side. The angle between them is 180 degrees. Now theta is 180 degrees. They are in opposite direction. They are in opposite direction, anti-parallel. They are anti-parallel, unlike vectors, anti-parallel vectors, unlike vectors, right? Opposite direction, theta 180. Then the flux, the measure of the flux coming out of the flux, out of the element, the measure of the flux with respect to this area element to ds. We know again d phi is equal to E dot ds. Flux is the dot product of electric field intensity and area element. So therefore d phi is E dot ds. So d phi is equal to mod E mod ds cos of the angle. Now the angle is 180 degrees because both are in opposite direction. Field is in this side, field is in this side, in this direction. I am considering the area, surface area to be like this. So the lines of force are falling on it. The lines of force are falling on it. Area element is this side. This side, the normal to the surface represents the area element, and the field is in that direction. Both are in opposite direction. Angle 180 degrees. Opposite. Then we know according to trigonometry cos 180 is minus 1. So it's mod E mod ds cos 180 minus 1. So the flux is minus mod E ds, or d phi is equal to minus E ds. This is called negative flux. Mathematically I have got it as negative, minus, but what do I actually mean? The meaning of it is the lines of force are moving in this direction and our surface area is this way, such that the normal is away in this direction. So the lines of force are falling on the surface. Now this is termed as falling flux. The lines of force falling on the surface. This is incident flux. Falling flux, the flux falling on the surface. Entering flux. Initially when theta was 0, it was emerging flux. Now it is entering flux. The flux is entering into the surface. Entering flux. Falling on the surface. Whenever the lines of force fall on the surface, you need to remember it as negative flux. Falling, incident. It is entering into the surface. Then it is negative, minus. In the earlier case, when theta was 0, when the lines of force are emerging out of the surface, lines of force coming out of the surface, coming out of it, emerging, right? Then emitting flux, emitting or emerging flux. Emitting, emerging or coming out of the surface, that is positive. Entering flux, incident flux or falling flux, the lines of force falling on it, now that is termed as negative flux. The flux is said to be minus, negative like this. Right? You know, actually, when you look at this formula, E dot ds, mod E mod ds cos of the angle, you know, cos according to trigonometry, for all angle theta ranging from 0 to 90, for all values ranging from 0 to 90, the cos value is positive. So, acute angle, right, cos positive. So, if the area element, the electric field is like this and the area element is like this, the angle between them theta is less than or equal to 90. For all these values, acute angle, the answer is positive. It is emerging out of the surface, that is emitting flux, positive. Suppose if I consider, if the electric field is like this, but if I consider the area element in this direction, where the angle is more than 90, 180 obtuse angle more than 90, right, obtuse angle, then in such case the flux is negative. It is incident flux. So you need to remember mathematically, formula wise, for all angle ranging from 0 to 90 acute angle, right, the flux is positive. For all angle theta greater than 90 up to 180, greater than 90 up to 180, it is negative flux, minus flux, right? Thank you.